So welcome back guys. Today again we have some very good problems from the Allen score test series, and I also noticed one JEE advanced PYQ which I guess needs to be discussed from integration. Okay, I just gave the reveal for the chapter, but yes, that's a very good problem and also a very difficult problem, because most of what I had observed is most of my batchmates called this problem a god level problem from JEE advanced, so I thought we could bring that in. Anyways, so, and I also saw that some of you were complaining that my screenshots were not so visible. It was hazy kind of. So what I have done is I have made the size big. I hope it is visible right now. And still, if there is any problem, please write to me. So this is it, and I will start off for today's problems. So you can try out this first problem for today, and I will wait for a few seconds. Okay, so I'm starting off. So guys, basically today's questions will be really good, okay? Because today I have brought some problems, like most of them are something which you might have never seen before. Like the difficulty level is very good, okay? I really like the problems from this particular segment, this paper. Anyways, I will start off with the first question. So basically in this question we have a polynomial function which satisfies this particular inequality, and we also have something given that f of 0 is equal to 0. So we have to find out which options are correct. So what we will do is, let's first write out the inequality, because that is the only thing given to us. So it is 0 less than x times f of y less than y times f of x for x comma y such that 0 is less x less y less 1. Something of this sort. So let's try to create something from this particular part. Now what we can observe is f of y, y and f of x, x. So that is y, f of y and f of x and x. They will look good together. So what we will do is we will write this as f of y by y is less than f of x by x. And now the striking point is, this is for, as per this inequality, it is 0 less than x less than y. Basically both x and y positive and x is less than y. Now what you will observe is, if x is less than y and f of y by y is less than f of x by x, it actually means that if we take a function g of x to be f of x by x, then this function g of x is actually decreasing. Okay, like we can write it out as g of y less than g of x. And now from this part we can say that this function is actually decreasing. So from decreasing, what we can infer is our g dash x will be obviously less than 0, because that is how we actually come to this conclusion that a function g of x can be decreasing. So now what we will do is, we know that g of x is f of x by x. So let's try differentiating this particular thing and coming to something. So I hope you guys know the question now, so I will try to change the page. So from this part, what we can actually write is, okay, first I will differentiate g dash x before proceeding. So this thing will actually become, first we will have x times f dash x, and then your minus of this thing actually will become f of x divided by x square. So now let's put this into this equation and see what is coming. So this thing actually basically comes out to be your x times f dash x is less than f of x. Why? Because the denominator has no use. This is less than 0, right? So that's it, and now we can write down f dash x as less than f of x by x. And this is for 0 less than x less than 1 from the inequality we had here, right? So now what we can actually say is, like, this is, you can observe the beauty of this question, right? We came from g dash x less than 0, we converted this to f dash x, and immediately we arrived to the conclusion that f dash x is actually less than your g of x. Like a very beautiful question. So what we can say is, because f dash x is less than g of x, so obviously I can say something like that f dash x will actually be less than the minimum value of g of x, right? Because it is less than g of x. So f dash x, I will write it also. F dash x will actually be less than the minimum value of g of x, which is nothing but your g of 1. Now you will ask why, because if you differentiate this equation, you can observe that we are observing a minima at x equal to 1. Okay, I will manipulate that because otherwise you guys will get confused. Just a minute. So basically, why did this thing happen? Because 0 less x less y less 1. So this is the value that you can actually have for the minimum value of g of x, and for g of x to be minimum, x has to be minimum, right? So that's it. And so we can write down that f dash x has to be actually less than your, sorry, this become double dash, I will rewrite. F dash x is less than your, just a minute. So I changed the page, I took it a little up to show you something. Basically what we will write is, here we can write g of 1, right? Now g of 1 is nothing but f of 1 from this expression. So what we can say is f dash x is less than your f of 1, which I guess was present in one of the options. Okay, this is a very good conclusion we arrived to. I will check the options later on. First, let's verify out if we have something else. I will just look at the options once for clarity. So basically f dash x less than f of 1 makes A correct. And we have something else also with us, like there is some f of 1 less than 2 times integral something. I can see something like this. So basically I guess we have to do some integration. So for that we already have a differential form ready, right? That f dash x is less than f of x. It is somewhere here. So I guess we can use it. Let's do that quickly. So basically we had the inequality with us as x times f dash x is less than your f of x. So now what we can do is, I will integrate this on both sides from 0 to 1, because in the option we had that, right? So x f dash x dx less than your integral 0 to 1 f of x dx. So now you can see this is a clear by parts thing. So now we will take u integral v dx. So let's take this thing as a v and this thing as u. And now I guess it is pretty simple. So x times f of x from the limits 1 to 0, sorry 0 to 1, minus integral 0 to 1 x differentiated 1 and fx dx is less than your integral 0 to 1 f of x dx. So basically from this thing we will finally have our f of 1 on the left hand side, and this goes to the right hand side to become less than 2 times integral 0 to 1 f of x dx, which basically makes our option B also correct. And now we have to like check in between options C and D. So let's do that. So in options C and D, basically what we have to do is, all this 3f of 1 by 3, you can understand that it is f of 1 by 3 divided by 1 by 3, right? So this form. Basically we have to compare. So we have already found that our g of x is a decreasing function, right? So let's say, let's take C. Okay. So you know that the value of 1 by 3 is approximately 0.33 and the value of half is 0.5. So basically we can write that 1 by 3 is less than half. 0.3 is less than 0.5. So from there what we can write is g of 1 by 3, because g is a decreasing function, so it is greater than g of half. And now if you turn this to f, you will understand that your option C is actually correct. Basically if you don't have to turn this to f also, right? And now if you check number option D in a similar sequence, what I will do is I will just compare the quantities, because as we have found this thing to be correct, we can infer from this step only, right? So 1 by 6 is something, I guess, approximately 0.16, and 1 by 5 is 0.2. So 1 by 5 is greater than your, or I will write in a similar way, 1 by 6 is less than your 1 by 5. So if 1 by 6 is less than 1 by 5, then from this thing, f of 1 by 6 multiplied with that constant should be actually greater than f of 1 by 5 multiplied with its constant, but it is given to be less than. I think it's easy to infer from this, okay? So our option D is actually wrong. So the correct options for this will actually be A, B and C. This was a good question. Although I would like to tell you guys one thing. I will go on to the options once. Basically, as you can see here in option A, it is given to be f dash x less than f of 1. And we have found this out here. Okay. But I saw the answer key. In the answer key, it was written the answers were B and C, which I guess is actually wrong. Because we clearly proved that option A is correct, right? I guess on the answer key is somewhat wrong. I got A also to be correct. Although I have solved this for the first time, I will try to verify once for sure. And if I get anything, I will update you in the post section. Okay. So up till now, the correct answers are, you can say they are A, B and C. So let's move on to the next question. So here's the next question, guys. So basically, this is not from Alan AIOT. This is a JEE Advanced 2021 PYQ. I hope the size is clear and I hope this is visible. I tried maximizing it as much as I can, like as much my screen can fit. I hope this is pretty clear and visible. Otherwise, you can like write down the question, and let me tell you guys, this is a very good question. Okay, I guess the most difficult question in maths from that paper. Like this involves almost all the concepts that you have learned in calculus. So it's a very good question. You can say a god level question. Now my idea of doing this right in between is because we just solved something on integrals. So nothing for a greater time to solve this right now. So I will give you, maybe this will take longer than few seconds. You can take about, like this is a paragraph type question, right? So you can take about 15 minutes. Okay, no heed, because this is a very difficult question. You can take about 15 minutes to solve, and I will wait for a few seconds for you to pause the video. After solving this question for about 15 minutes, you can come back. Okay, so I'm starting off now. So basically we have some information given, like this is your f of f ranging from 0 to infinity, g ranging from 0 to infinity, and all mapping to real numbers. And also one thing is given, f of 0 is equal to g of 0 is equal to 0. Some information like this is given to us. And we also have something given. If you don't know about this letter, this is actually called xi. If you have studied atomic structure in chemistry and modern physics, then you will know that this letter is very much used in our atomic wave function. Okay, that's Schrodinger wave equation. Anyways, that's out of the topic. So it's like a variable used here, and we have such information given, like xi 1 of x given to be e power minus x plus x, 1 xi 2x, which is equal to x square minus 2x minus 2 e power minus x plus 2, where x is in both of these greater than equal to 0, and f of x is given to be your minus x to x mod t minus t square e power minus t square dt, and here g of x is given to be your integral 0 to x square root t e power minus t dt, where x is greater than 0. So this is the summary of whatever is given to us in the question. And now this question might actually seem difficult, but it's not difficult. Okay, it's basically, they have, if you correctly observe the options in the two questions, like even the questions say which of the following statements are true. So you can say that in 4 plus 4 they have given you almost 8 questions, 8 small questions which you have to solve, like determining the properties of these and looking into them. So basically the question is not difficult, it's actually clumsy. So what I will do is, I have written the questions down here, so I have no space anymore. I will change the page and go on to the next slide, okay, where I will solve the sum. So I am changing the page. So first of all, what I will do is I will do some manipulation with f of x, because that's the first thing I actually noticed, okay. So f of x is your basically integral minus x to x, and this is your mod t, and I guess it was minus t squared times e power minus t squared dt, as far as I remember. Yeah, it is correct. So now if you observe this function carefully, like if you see, f of x is actually equal to f of minus x, okay, or rather I will not consider f of x here because x is in the limits. You can take this function to be some g of t, say, okay, g of x is already given, so let it be, say, k of t. What you will observe is actually k of t is equal to k of minus t, so it is an even function, okay. So what we can do is, because this is an even function, we can write this as 2 integral 0 to x mod t minus t square into e power minus t square dt. You will actually observe, using very fundamental concepts, we will solve this very like difficult looking question. So what I will do now is, I will differentiate this equation once. I will write f dash x. You will slowly understand why. So this is basically, it will become 2 times, and we don't need mod t. So because x is positive, it was greater than equal to 0. So 2 times x minus x square into e power minus x square, and dx is not needed, I'm sorry. This is your f dash x. So now if we see, this thing is always positive, and this thing comes out to be your x times 1 minus x. So now if we put this equal to 0, and if we see the roots, they are 0 and 1. And if we try to draw a wave, it will be something like this, okay. And we can't take this region. Why? Because it's debarred. X is always greater than or equal to 0. So this is the thing. This part is minus and this part is plus. So now let's look into the options once. Now what I actually differentiated this equation for is, because I hope you guys can understand that I am looking at the options, okay. If you observe in question number 15 in this screenshot, what you will actually observe is that option D has f is an increasing function in the interval 0 to 3 by 2. So 3 by 2 is basically somewhat 1.5. So as you can observe, 0 to 1 the sign was positive in my number line, but beyond 1 the sign was negative, which means it is not continuously increasing. So in question number 15, okay, I will write the options here and put a cross or tick on the basis. So in question number 15, our option D actually becomes wrong. First option eliminated. So now let's look on for the others. Okay. So if you guys actually observe in the options, there was something of the sort f of some root ln 3 plus g of some root ln 3. And we had to find out the value. Now what most of you guys might think, that how can we integrate those two bulky expressions which were given, okay, that f of x and g of x. Like even using by parts, it will take a lot of time. So that's the trick that they have played with you in this question. What we will actually do is, we will find g dash x. Okay. So if you remember g of x, g dash x actually comes out to be x e power minus x squared, and this thing actually becomes your, I will just look at g dash x and g of x and tell you. Okay, and this thing becomes your 2x multiplied. Yeah. So this is our g dash x, and if I take the screen a little bit upward, we have f dash x also ready with us. So now what I will do is, I will add on f dash x and g dash x. That's the beauty of this question. What you will observe is 2x e power minus x square minus 2x squared times e power minus x square, and that is what we have here. So that x square and x square term, these both get cancelled. So what we have left over is 2x e power minus x square. So now if you have like little bit knowledge of differentiation also, then you will understand that if we integrate both these sides, this to dx and both of these also to dx, then this is obviously f of x plus g of x, and this thing is nothing but the differentiation of e power minus x square, or rather not e power minus x square, it is your minus of e power minus x square, because this minus will come here. So because there is no minus sign present, so a minus sign should also be there, and this is your plus constant. So basically, to find out this constant, they had given us something which is f of 0 equal to g of 0 equal to 0. Like there are small hints hidden everywhere, right? Because you have f of 0 and g of 0 both given equal to 0. That should also give you a hint that maybe f dash x and g dash x might appear in a similar sort of expression together. Like these small things can be hints, okay? Like how, depends on how you take them. Anyways, so If we put these values, we will have 0 plus 0 is 0, equal to e power 0 is 1 plus c. So basically our c becomes minus 1. Or rather, okay, it's not minus 1. This was minus 1, okay. So c equal to plus 1. So our f of x plus of g of x comes out to be your 1 minus e power minus x square. This is our f of x plus g of x. And now we had f of root ln 3. I guess root ln 3, right? Yeah. Plus of, I guess, g of root ln 3. So if we evaluate this, pretty simple. This will come out to be your e power minus x square. So e power minus root under will get squared. So e power minus ln 3. So this is basically 1 minus 1 by 3, which is your 2 by 3. And now we will check what was given in option number A. So basically our option number A says that it will be 1 by 3, but our result is 2 by 3. So option number A is also wrong. Basically, if you observe this question, actually the difficulty there are various ways because of which this question becomes difficult. First is the question is really big in size, and you can see all this dirty equations and all given, which will actually frighten anybody who is solving this in the exam hall. Okay, first thing is they will actually induce into your heart a frightening mind that this question is difficult, I can't do this. This is what type of mentality actually JEE advanced people, the people paper setters, they actually want to induce in you. And second thing is, if you observe carefully, especially in option number 15, you can't determine anything, like although this is single correct, but you still can't determine which is correct. Okay, you have to go with solving everything from top to the bottom. You have to go with solving everything from the top to the bottom. Okay, and that depends on, like, if you get the correct option in first by chance, then it is by luck, very good. But if generally you don't know, right, that whether which option among these is correct. So actually you have to evaluate everything that is present. Basically you have 4 different questions. So that is it. And that is some pretty reasons why this question is a very good question. Okay, so now we have shortlisted ourselves to option B and option C. So let's see what we can do with them. So now before proceeding, if you observe option B and option C carefully, these are just like those small limit questions that you have done in your RD Sharma. Basically, I don't know if you guys remember, basically we had something like a small function was given to be f of x, and we were given some interval of x and said that there will exist some sort of, you will see these in RD Sharma exemplar also, we have some sort of number that is lying in between some, say here we have alpha and beta, alpha belonging from 1 to x, so they will give something like that and say, then they will say that there is such a value such that this particular function is equal to something. Okay, so now there is no actually sort of direct method to determine whether this function, say here it is given as phi 1 xi 1 of x, not phi, xi. So you will not have any clues whether that xi 1 of x is actually equal to this. How will you like determine out of the blue? But they have given you something like B and C, they have given you options. You can basically therefore treat B and C as type of proving. Okay, you have to prove whether these and this are actually equal or not, whether B is like what I will say, B is true and C is true. So what we will what my point of telling all this was, we will actually take a separate function. Say I am solving for B. Okay, I am solving for B. I will take a separate function which is equal to phi 1 of x minus 1 minus alpha x. That is, I brought this thing in the RHS to the left hand side. We will take this function capital H of x to be phi 1 of x minus 1 minus alpha x, and then we will evaluate that particular thing and see whether that function is actually increasing or decreasing, and after that we will have an idea. That was basically the point of saying all this. I hope you have done similar small questions based on this topic, because when I learned limits I had also done. So I hope you guys have also done. Okay, so let's go on to proving this and like seeing whether it is correct or not. So as I said, what I will do is I will take, say, a function capital H of x, which is your phi 1 of x, sorry, xi. I am telling phi repeatedly, it is xi. Okay, xi 1 of x, and this is your minus times 1 plus alpha x. I wrote this in a bracket. so that you understand that we have brought this from the right hand side of that equation. So now if you evaluate, like put the value of xi1x here, it will actually come out to be your e power minus x, and this is your plus of, I will not put plus, I will directly put minus 1 minus alpha x. This is your, I guess, xi1 of x, and this thing is your, as per given in the question condition, for x greater than equal to 1 and alpha belonging to 1 to x, both open. So now let's check at the corner points, I mean the points of interval. Okay, so if we try to find out our h of 1, this is e power minus 1 minus alpha, and if you guys notice carefully, this thing is less than 0. I hope there is no doubt in this. And okay guys, just a minute. Okay, I actually missed out something, I guess. I will just check on xi1 of x and tell you. So there was a small mistake. This is actually will have your plus x. I don't know why I missed this. Anyways, so now we can add on a plus 1 also here. That was what I was missing. So basically your plus 1 and minus 1 will get cancelled, and e power minus 1. So 1 by 2.3 is 0 point something, like very small, and alpha belongs to 1 comma x. Okay, and x is greater than equal to 1. So basically 0 point something minus a value which is 1 point something, or maybe greater than 1, whatever. So obviously this thing will be negative. And now if we try to observe h dash x, we differentiate h of x. So this thing becomes minus e power minus x plus 1. Minus 1 is gone, it is a constant, and minus alpha. Still, if you see this, this is also actually less than 0. Why? Because alpha is belonging to 1 to x, like some value greater than equal to 1. Say if I take x to be 2, so alpha is belonging to 1 comma 2. So minus 1 point something plus 1, and after that you will have minus 0 point something, and this thing is again minus of e power minus x. So minus 0 point something, and this is also minus 0 point something. So basically you are adding two negative quantities, which means that this thing will be less than 0. So potentially from here what we can say is our h of x is actually decreasing. It's a decreasing function. And now what was given to us, if you read, I will read out the question's language once. So our option B's language says something of this sort: for every x greater than 1, there exists an alpha belonging to 1 comma x such that phi 1 of x is equal to 1 plus alpha x. But now we have proved that this h of x function is actually decreasing, which is equal to phi 1 of x minus 1 minus alpha x. So it cannot be equal, right? So basically I will put a cross here, and our option B becomes wrong. And now I guess you can automatically get that our option C is correct, but I will still solve it out. Okay, there is something similar in option C, sort of similar, that you have to solve. Like option B and option C are actually very similar. So in the exam hall, if you get by chance, if you take option C first and solve it, maybe you are in good hands. Anyways, we have to consider all probabilities. So A, B, D are all eliminated, and C is correct because it's a single correct option. So C will all obviously be correct, but still I will solve it for you. So moving on to our correct option C, like we are re-verifying it sort of. So what I will write is our xi2 of x. And it was, I guess, given to be 2 times xi1 of some quantity beta, and this is your minus 1. So what I will actually do in this portion is I will apply our that theorem which we applied in last class also, like last video, our Lagrange mean value theorem. And that is why in last class I told that if you guys don't still know this, please know it, because you can see that now in a JEE Advanced 2021 question we are using Lagrange mean value theorem. So let's apply it for xi to x in the interval given, which is 0 to x. So now if we apply this, what we can write is, I am actually, what is the point of applying, because beta is given. So what I will do is I will write xi2 dash beta, and this thing will be equal to your xi2 x minus of xi2 0, right hand limit minus left hand limit, and this is whole divided by your x obviously. So what we can see is we have xi2 dash beta. And for that, we need to differentiate xi2 of x, right? So I will directly differentiate xi2 of x. I hope you guys know what it was, or whatever. I can write it also. Otherwise, there will be problem. So xi2 of x, actually it was our 2x minus 2 plus 2 e power minus x, right? And this thing, if we differentiate xi2 dash x, it actually becomes 2 minus of 2 e power minus beta. Okay, and I guess I will check once. I guess I missed out something in xi2x, and there was a minus 2x also here. Okay, so this thing will actually have one. Okay guys, I will just check on this once. I'm making a mistake. Just a minute. So here's our xi2 of x, guys. I'm sorry for the inconvenience. I did some mess up here. So now we can differentiate this xi2 dash x. This thing is your 2x minus 2 and plus 2 e power minus x. This is your xi2 dash x. And now we can find out xi2 dash beta just by putting beta in this equation. So what I will do is I will directly write out the statement for LMVT we wrote in the last page, which is your 2 beta, and this is minus 2 plus 2 e power minus beta. This comes out to be equal to xi2 of x minus, we also had xi2 of 0, right? I guess, yeah. So if we try to find out xi2 of 0, it's actually coming out to be your 0 e power 0 is 1, so minus 2 plus 2, which is your 0. And this thing is whole divided by your x. So what we can do is we can write this xi2 of x is equal to your x times 2 beta minus 2 plus 2 e power minus beta, right? This is the thing we have. So basically now what you can do is we can easily write this thing as your, like, the result we actually had. We can take 2 common out, 2x. So we will have your beta minus 1 plus e power minus beta. And as you can observe, if we leave out our minus 1, this thing and this thing actually make up xi1 of beta. So xi2 of x is equals to 2x times xi1 of beta minus 1. So indeed this option is correct, and this actually have a solution, actually one solution, okay, from our expression of Lagrange mean value theorem. So for question number 15 here, our correct option is option C. So you can understand the level of question, and still the question is not complete. We still have something more to go. So let's proceed towards that without wasting time. So before solving, let's take a small look at question number 16. So basically it says that xi1x is less than equal to 1, xi2x is less than equal to 0. So all these things we can actually determine from our previous whatever we have calculated, like the differentiation forms and all. But in the options number C and D, there is something which is bit complicated, and for that we actually have to apply by parts. Like, it is sort of bad news in the exam hall, but we have to, okay. So let's quickly do that. What I will do is I will try to solve options A and B quickly. Like, I am trying to give you a real representation of what could have happened if you were present in the exam hall in 2021. Because C and D, you can observe, it's pretty tedious to solve, and you don't know whether C and amongst C and D any of the options will actually be correct. Okay, you still don't know. So we have to solve it all. So let's start off from options A and B directly. Okay. So here's our your question number 16. So going towards your option number A. So we had our xi1 of x, which is equals to your e power minus x plus x for x greater than equal to 0. So if you observe our xi1 dash of x, although we have already calculated, but still I am writing this is 1 minus e power minus x. So this is basically your greater than 0. Why? Because e power minus x, so 1 by e power x, quantity which is 0 point something. So this thing is actually positive, which means your xi1x is an increasing function. And now if we observe, xi1 of x is an increasing function, so xi1 of x will obviously be greater than or equal to your xi1 of 0. And This is for all x greater than equal to 0, which was given to us in the question originally, which basically means that xi1 of x will be greater than equal to 1. Why? Because xi1 of 0 is 1. This is your e power 0 plus 1, right? Which means our option A is not correct because it was given to be, I guess, not this. So similarly, in option number B, something similar will happen if we take our xi2x. Like you can see, right, xi1x, this option A and option B is just quick stuff that you have to solve and go out. Like we still don't know if option B will be correct. If that is correct, then it's a very good thing, but unfortunately it is not. Okay, I gave you a blooper also. Unfortunately, A and B are not correct. Something among C and D will be correct. So you can observe the difficulty level of this question if you come solving from right from A. Okay. So now xi2x was given out to be 2x minus 2 plus of 2 e power minus x, and also I forgot plus x square for all x greater than equal to 0. So once again, if we calculate xi dash of x, this comes out to be 2 minus 2 e power minus x plus 2x. And if you observe, this thing can be actually written to be your 2 times xi1 of x minus 2. Similar to the option number C that we solved in the previous question. So obviously this thing is greater than equal to 0 because xi1 of x is an increasing function, right? For all x greater than equal to 0. So it's already proved, and now we can also say that xi2 of x 2 is an increasing function, which means your xi2 of x will be also greater than equal to xi2 of 0. And now if we try to find out xi2 of 0, although we have already found it out, this actually will come out to be 0, plus 2 and minus 2. So from here we can conclude our xi2 of x will be greater than or equal to 0, which means option B is also incorrect. Now let's move on to the option C and option D, and let's try to figure out what we have to do. So as you must have observed, our option C and option D, they had given f of x greater than equal to some huge e power expression. Now that sort of an expression will only come when we try to solve it. So now no more differentiation and all, we have to try to directly solve the integral. So let's write out of f of x, which was given, we had found rather 2 times integral 0 to x. And because x is positive, we don't need to write mod t, we can directly write t minus t squared, and this is your e power minus t squared dt. And I will also write x belonging from 0 to half. This was given. So now you can actually adopt different methods to solve this. Some people, there will be a category of people who will take t square equal to u. Although only by parts is the main method, but what I'm doing is I'm convenient without like doing another substitution. Okay, so I'm solving it directly in terms of t. So now we can split this into two integrals. What we'll write is integral 0 to x 2t e power minus t square dt. This is your minus t square, and this is your minus integral 0 to x 2t square e power minus t square dt. Right. So this is something you can easily observe, that substitution for t square will put this to be 2t. So no more, like, I am not going into the substitution and all. You can take e power minus t square and as u, then you will have 2t times e power minus t square as du. This will automatically come out to be your minus e power of minus x square, and limits will be from x to 0. I put the original limits because I have not done substitution. And this is your minus integral 0 to x 2t square e power minus t square dt. So now what you must be wondering is, how can we find out this thing? Now you can apply by parts, but this thing will actually be pretty tedious. Okay. And now another thing that you will observe is solving this can take away half your time. So what we will do is, I will copy the expression that was exactly given in option number C. Let's look at that once. So our option C says it is 1 minus e power minus x square minus 2 by 3 x cube plus 2 by 5 x power 5. So let's copy this directly. Like, I hope you can understand what I am hinting towards. We are hinting towards something that we did in the like I guess option numbers B and C in question number 15. I will do that quickly. I will write this down first. So because we have already used that capital H of x, let's take some P of x. Okay. And now I will write this to be your f of x minus 1 plus e power minus x square plus 2 by 3 x cubed minus 2 by 5 x power 5. I guess this, and I will quickly check the signs once whether they are correct or not. Yeah, so the minus I just put them all and the signs are correct. So now what, this is between x belonging to 0 to half. So what I am actually doing is we actually are, if we try to find out p of 0 ones, okay, f of 0 is 0 minus 1 plus 1 plus 0 minus 0, so this becomes 0. So we have p of 0 equal to 0. And now what I will do is I am going to take a sort of risky step. I don't know whether this will work. Okay, I am trying to differentiate p dash x, and let's see what happens. So differentiating p dash x, what we'll actually have is, and that's why I actually left this integral at this particular part. Basically this thing is some constant, right? This is some constant, and p dash x will actually come out to be, I will simplify this for you guys once, just a minute. So this thing actually comes out to be, I will write the simplified form. This is 2 times x minus x square, and because there was integral here, you are actually applying L'Hopital's, right? We are differentiating this. So and also e power minus x square here, and minus 2x e power minus x square plus 2x square and minus of 2x power 4. So if you simplify this a bit, this will actually come out to be our minus 2x square e power minus x square, and this thing I guess we will have a minus 2x power 4 plus 2x square. This is your somewhat p dash x, and now if we try to take a 2x square common because it's present in all the terms, this will be 1 minus x square minus of e power minus x square. This is what we will have. And now we have to ascertain something about the sign. So what I will do is, basically we have to ascertain the sign of this expression, right? Let's take this to be some q of x. Q of x is your 1 minus x square minus e power minus x square. So now I am using little bit of a trick here. 1 minus x square minus e power minus x square. So if we find out the relation between e power minus x and 1 minus x, sort of similar relation will be followed in also in between these two. So what we are doing is e power minus x minus of 1 minus x. We are trying to find out the sign for this thing. So I guess if you put like 1 minus 1, so 1 is not a good value, you can put x equal to 2. And as far as my calculations say, if you put x equal to 2, this is actually coming out to be or greater than equal to 0. Yeah, this is coming out to be positive. So e power minus x is actually greater than equal to 1 minus x. And from there we can say that e power minus x will actually be greater than equal to 1 minus x square. This is 1 e power minus x square. So basically the sign of this is actually negative, and 2x square, x square is a square, so always positive quantity. Therefore this complete expression is less than 0, which means our p of x is actually decreasing. It's a decreasing function. So pretty amount of good evidence we have arrived after solving this so much. So what we can say is that because p of x is decreasing, therefore we can say that 1 minus p of x will be less than 0 for all x belonging to 0 to half. So basically I guess in this expression, I will just check the sign what it was given. So our option C actually says that is greater than or equal to, but no, it is less than or equal to. So option C automatically becomes wrong, and we have our correct option D. But still, let's not leave it because we have come so long. I will solve out option D also in a similar way. Okay. So let's go on to option D. Option D will be somewhat similar. You don't have to worry. So let's now take some r of x. I'm using different letters because we have taken multiple functions. So let this thing be your g of x, and similarly we take that expression also to the left hand side of this. So just a minute. So this thing becomes your 2 by 3 x cube plus of 2 by 5 x power 5 minus 1 by 7 x power 7, and I guess nothing more. And this is also for your x belonging to 0 to half. So now what we can do is, in a similar way, we will differentiate this thing also. So what we will have is your, I'm writing this thing directly, okay? I have calculated this right now. I am writing this particular thing directly. You can match with yours. So this thing actually will become 2x square e power of minus x square, and this is your minus 2x square plus 2x power 4, and this will actually be minus x power 6, x power 7, so 7 7 cancelled, x power 6. And now what I will do is, we will not go into like ascertaining this again in terms of something and all, because this process is becoming a bit tedious. I guess I should have done it in the last option C also. This just came to my mind. You can, if you guys haven't, are not doing this question live right now, you can, whenever you solve it, you can do this also in option number C. Okay, what I will do is, we know that e power minus x square can be expanded, so I will put down the expansion for e power minus x square actually here. You can do this in the last option also. Actually the thing will actually be simpler, because finding all this out will take longer time than simplifying a few powers. And this will be your minus x power 6 by 3, and this is up till infinity, we don't know, and minus 2x square plus 2x power 4 minus x power 6. So now if we simplify this particular thing, you will actually observe what we have is minus x power, we will have 8, I guess. I hope I'm not wrong with the calculations. Yeah, we'll actually have minus x power 8 whole divided by your 3, and this thing will come out to be plus x power 10 by 12, and then dot 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 till infinity. We don't need these terms. So this is what actually we will have. So if you observe once again, p dash x will be less than, I'm sorry, not p dash, r dash x will be less than or equal to 0. Now if you still can't if you can't understand from here, what you can do is, you can take this particular part to be another expression and differentiate this again, but I don't need, you will actually have the need to do that, because our x is belonging to 0 to half, so just put some random value, right? Like you can put 1 by 4 or something like that. Anyways, you will like just put 1 by 4, this will come out to be minus 1 by 3 times 4 power 8 plus 1 by 12 and 4 power 8 in the denominator. Then take out 4 power 10, I'm sorry. Then take out 4 power 8 and just do a little manipulation. You will understand this is less than equal to 0. I had done this already, so I am not doing the calculation part. So basically same thing for our r of x, it is also decreasing. All the functions given here were actually decreasing functions. Like xi1 also, xi2 also, r, p, g, f, everything. So anyways, the final conclusion is r of x is less than equal to 0. And now if you put our r of x here in this expression, you will get your correct option D. So here's the JEE Advanced 2021, one of the most difficult PYQs done. And this, I guess it took a lot of time also. It took a real amount of time. Although you will not have this much of time, like I am doing this on screen, so my writing is slow, and the other factors you consider while doing speed, they are a little bit slow, but when you are using pen and paper, this has to be done within 15 minutes. Okay, if such thing comes again in future. So that's what you should keep in mind. Speed is everything. Not like everything, but inside the exam hall, when you are inside a time constraint, speed can change many things for you. It can change your fate, it can change your rank. So anyways, we are done with this PYQ, and now I will, I guess, return to some more Alan questions. So here's the next question, guys, for today from Alan. And I will give you a few minutes to solve this. Although this is not very difficult, but still, you can try it out. I will wait for a few seconds. Okay, I am starting off now. So basically we have something given, a quadratic equation a z square plus b z plus c equal to 0 in complex numbers, and its roots are told to be z1 and z2. So basically our mod a, mod b, mod c all are 1. So we can use sum of roots and product of roots to find. So we will have mod z1 mod z1 z2 to be equal to c by a, which is 1, and your mod z1 plus z2 to be equal to mod of minus b by a, which is also 1. And now what we will do is, because we have mod z1 plus z2 equal to 1 in option D. So we already got an option correct just by doing this much. So now let's go on to solving something furthermore. Basically we have to, in option A it is given b square equal to ac. Okay. So let's try to derive that. So I have some idea in mind. What I will do is, I'm changing the page, okay, otherwise this will not be visible. So what I will do is, I will write z1 plus z2, which was equal to r1, and if you know, we can actually multiply this with the conjugate. Why? Because mod z1 plus z2 is equal to 1, and mod z1 plus z2 is z1 plus z2 into its conjugate. Simple stuff. And now what we can do is, we can write z1 plus z2 multiplied by your 1 by z1 plus 1 by z2. I hope this is clear. And this thing is equal to 1. So this thing automatically becomes z1 plus z2 whole square. Why? Because divided by z1 z2 it was 1, and this thing is equal to your, okay, z1 z2, I'm sorry, it was mod z1 z2 equal to 1. So z1 z2 actually gets shifted to RHS. I'm sorry. So now what we can do is, we can actually put the expressions that we had for these. We had mod z1 plus z2 to be equal to your mod minus b by a, and mod z1 z2 to be equal to c by a. So if we remove the mods, these will be the expressions we have. So we can clearly write b square by a square, b square by a square to be equal to your c by a. So from here we have our b square equal to ac. Pretty simple to prove, just little bit of properties. And now we also have to find something else. I will look at the options. So basically we also need to discover the value of theta, and I guess one PQ is also given. Okay, we will read the question once. This is P and Q are the points representing the complex numbers Z1 and Z2 respectively in the complex plane. Okay, this means that if this is the complex plane, and if this is the point P, and say this is the point Q, and this is your origin of the complex plane, so POQ is actually our angle theta. Okay, I understood. So we have to find theta, and for that we'll quickly do something. I will change the page. So what we'll do is, we'll rewrite mod z1 plus z2. And now if you observe that angle POQ is the angle theta, right? So basically what we can do is, we can write mod z1 is mod z1, and with reference to z1, like z1 complex number, we can write z2 as mod z1 e power I theta. I hope this is clear. E power I theta is your Euler's form, sine theta plus I cos theta. Basically, if you want to, like, if I want to describe this in detail, in the complex plane, if you observe, that point will actually be your sine theta comma cos theta. Like if we take z1 as the base, right, and then construct a right angle triangle, then z2 will have the point to be sine theta comma cos theta, and then we will write it as in the Euler's form, sine theta plus cos theta plus I sine theta. Okay, it's not sine theta comma cos theta, it will be cos theta comma sine theta, and then for the Euler's form we will write cos theta plus I sine theta, and then finally we can write it as e power I theta. Although this was not, like, I didn't have to mention, but still I explained. So now we can write this as your mod z1 times 1 plus e power I theta, also whole mod, and this becomes, I guess, this will be equal to 2 cosine of theta by 2, 2 cosine theta by 2. Mod z1 will get, like, if we observe carefully, your mod z1 is equal to 1 from the previous results. Okay, just a minute. Yeah, so our mod z1 was already given to be 1 in the question itself, I just observed. So this will be your 2 cosine theta by 2. I don't think I have to explain this particular point. Okay, we are basically doing our cos theta plus I sin theta, and then we are opening the modulus. So this thing has been given to be equal to 1, right? So cosine theta by 2 is your half, and theta will become your cos, like theta by 2 is your pi by 3. So theta will become your 2 pi by 3. So basically another option was correct. Theta equal to pi by 3 was given in one of the options. I don't remember which one. I will check. I guess in option number B or C. Anyways. And now we can find out PQ. Basically PQ will be if this is your point P, which is your Z1, and this is say your Q, which is your Z2, and this is the origin, and this is your angle theta. We have to find this particular distance. Or if you like have studied those inequalities of complex numbers, there we actually take sometimes help of vectors also to study complex numbers. Okay, like it's very similar. If you observe that triangle inequality we have in complex numbers, it's very similar to proving and easier to prove and explain with vectors. So if you treat this like a vector also, basically we have to find out mod z2 minus z1. So pq is your mod z2 minus z1, which is your mod z1 times, you can write e power I theta minus 1. And now if you manipulate this thing, put cos theta plus I sin theta and manipulate, this is actually your 2 sin theta by 2, because it's your minus 1. So 2 sin theta by 2, and this is your 2 sine of pi by 3. So 2 sine 60 degree. So this is root 3. So basically all our options are correct for this particular question. So that's it, guys. I will proceed to the next question now. So here's our next question, guys. And for solving this particular question, some really cool manipulation has to be done. Basically, okay, I will not give you hints. First try it out and I will wait for a few seconds and then come back to the solution. Okay, so I'm starting off. So basically we have Tn cube plus of 2Tn equals to Tn plus 1. This is our base expression which is given to us. Now if you observe carefully, A, B are one question and C and D are two different questions. Basically in this particular question, we have to manipulate this base expression as per the need of the question, as per the question needs us to do. Okay. And also we have something else given, T1 is 1. So what I will do is, for solving, like, I guess one among A and B have to be correct, otherwise two options won't be given. So let's take, say, the option A comma B like this, and let's take the expression. It is sigma n equals to 1 to 100 Tn cube plus of Tn plus 1. And this thing is your, like, we have to find T101 plus something, it will come out to be. So basically what we will do is, we can actually, for this particular question, we can write Tn cube, and I will take one Tn to that side. So Tn cube plus Tn will be equal to Tn plus 1 minus Tn. And now you can add on 1 to both sides, so you will actually have this particular expression. So sigma n equal to 1 to 100, and this thing is your Tn plus 1 minus Tn plus 1. I will change the page, guys, otherwise I will have difficulty solving. So now as you can see in this particular expression carefully, this is a difference expression and the terms will successively get cancelled. If you observe T2 minus T1, and then we will have T3 minus T2. So here the first term gets cancelled. So basically in the first pair we will have T1, and as you know, if the second term in the first pair remains, in the last term, or rather in the first pair, if the second term remains, in the last pair the first term will remain. So this thing will become T101. T101 minus 1, and this is your plus 1, T101 minus T1, and this is your plus 1 added 100 times, so plus 100. So this thing becomes your T101 minus 1 plus 99, so plus 99. This is your answer for the first question, and I guess A option will be correct. B will be wrong. So now let's move on to option number C. We'll see the expression once. So basically our option C contains pi, a multiplicative term which is n equal to 1 to 100 tn square plus 2. So according to this we have to manipulate this base expression. So what we will actually do is we have tn square plus 2, right? So I will take tn common from the LHS of the base expression. So this becomes tn square plus 2 equal to tn plus 1. So very simply tn square plus 2 is nothing but your tn plus 1 by tn. Now if you like do a pi to this thing will actually become your t2 by t1 into I guess t3 by t2 and dot dot dot. So this and this if they get cancelled, this and this will again get cancelled. Basically in the first fraction if we have the denominator remaining, in the last fraction we will have the numerator remaining. So if you evaluate this, this will actually become your t101 by t1, or rather your t101. But our option C says it is t100, so option C becomes wrong. So now let's move on to option D. Please see the expression, guys. I will change the page. So take a look at the expression. Okay, I am changing the page now. So now if we observe our option number D, this thing is your pi n equals to 1 to 100 and tn plus 1 by tn minus of tn squared. And now we have to find this out, what this will result to be. So basically, I guess this is nothing very difficult. If we observe our base expression, which was tn cube plus 2tn equals to tn plus 1. And we had already found this out to be equal to tn square plus 2. I am just exactly copying the same thing. This is your tn plus 1 by tn. So if you put this thing here, we will actually have 100 pi n equal to 1 to 100 tn plus 1 by tn. This thing will become your tn square. If you write, it is minus 2 to that side, so minus tn square will be minus of this plus 2. So minus tn plus 1 by tn plus 2. So this and this gets cancelled, so it is basically 2 multiplied 100 times, so 2 power 100. So our option D is correct. So basically the correct options for this question are option A and option D. This was just I guess some sort of manipulation, but yeah, good question. So now I will move on to the next question for today. Okay guys, what I will actually do is, because I guess this video has exceeded 1 hour, so I am keeping this video till here, and you can find out the next part of the video. I will upload it soon. I will upload the next questions which we had for today in the next part of this video. Okay. Otherwise this video will become too long because we spent too much time on that paragraph question. So that's it for today guys. I will end the video here, and the next challenge questions you will surely find in the next part of this video. Otherwise the video is becoming too long. So if you like this video, do like, share and subscribe. And as I always say, if you have any doubts, you can tell me in the comment section. So that's it for this video guys, and very thanks for watching.